Okay, so today's lesson is over composite functions, chapter 4.1. Now we've learned about different ways to combine functions. We've learned about how to add two functions. So like for example, if I have a function that is just, 2x plus 3, and I have a second function that is, x squared plus 1. And if I wanted to add them, well, I would just add any like terms, which would be, it would be 2x plus 4 plus x squared. If I wanted to subtract them, I would just take this, subtract it with those terms. If I wanted to multiply them, I would probably use the FOIL method or box method. And if I wanted to divide, I could do that. So we've learned about those 4 different operations. There is another way to combine functions, and that's what we're learning about today. We can also do something called compose two functions. Now, it's called the composition of functions. So, composition of functions has a certain notation to it. We know what the addition sign looks like. We know what a subtraction sign looks like. We know what a multiplication sign looks like, or sometimes it's a closed fill dot. We know what a division sign looks like. Composition of functions, when we compose two functions, it has its own special operator symbol, and that's this empty circle dot that you're going to see. That is not multiplication. That's the biggest thing that students do, is they confuse this notation and they think, oh, that's multiplication. It is not. It's called composition of functions, or it's a composite function, however you want to word it, okay? I'll write it a little bigger, but pretty much you will see f of g, and that is how it's pronounced. It's pronounced f of g. It kind of looks like the word fog. This little symbol in the middle, it's kind of a small little circle. It's called f of g. Sometimes they might have it in parentheses, and sometimes they might also put f of g of x, either way. And sometimes they might also just use this notation, f parenthesis g parenthesis x. Again, this is not multiplication. It's not telling you to take your f of x function and multiply it by g of x function. If that was the case, they would use either multiplication symbols. But in this case, whenever it has this empty unfilled out, that's called composite functions, and we are going to compose them. It's simply another way to combine two functions, which I'll go over on some examples in just a bit. Okay, but this is the notation, so just keep that in mind. When you see these symbols or this notation, it's asking you to compose two functions. So let's go ahead and do an example on how to compose two functions. So example number 1, let's say we're given two different functions. The first function is 2x plus 3. f of x equals 2x plus 3. The second function, g of x, is equal to x squared plus 3x minus 1. And the question, part A, is asking us to figure out what is f of g. Now this is one way to write it. They could also have asked us like this. They could have also asked us f of g of x. It's the same thing. Or they could have also asked us f of g of x. I just want to show you different ways they might ask you. These all mean the same thing. F of g just means, they could also write f of g of x, which just means to take g of x and compose it with f of x. Or they can also write it like this, f of g of x. Okay, same thing. But the question is asking us to figure out what is f composed with g. Now the order does matter. The f is first, and then it's composed with g. So the way that we do these problems, you start with the outer function, meaning the function that comes first. Now the first one is f. So I'm going to refer to my f function, which is this 2x plus 3 function right here. So I'm going to start with my f function, which is 2x plus 3, and I want us to write that. So I'm going to go ahead and have us write 2. Instead of x, I know our input is usually x, I just want us to write a blank set of parentheses, or you can even do brackets, and then plus 3. So what I've done, I took my f function, which is 2x plus 3, and I wrote it, but instead of x as the input, I just wrote 2 blank plus 3. Okay. Now what I'm going to do next is I'm going to take my inner function, that's the second function that they give us, which is g. It comes second. And our g function is this whole x squared plus 3x minus 1. And that is going to become the input of these brackets. It's going to be the input of my f function. So I'm going to have 2, and instead of these empty brackets, I'm going to replace it with this entire g of x function. So inside brackets it will go x squared plus 3x minus 1. And that's how we would compose the two functions. Now this answer is right. We would want to simplify, FOIL out, or distribute anything that we can. But this answer is right, and this is how we would set it up. Okay? And so then our last step would just be to simplify by distributing. So this would equal, well, I would take the 2, distribute it to everything inside the bracket. So it would be 2 times x squared is just 2x squared. 2 times 3x is 6x. 2 times negative 1 is negative 2. And then just bring down this plus 3. We didn't do anything with it. A lot of people try to multiply 2 times 3. The 3 is not in parentheses or brackets, so you don't multiply 2 by it. You just multiply 2 by whatever's in the brackets or parentheses. And then we go ahead and combine our like terms. We have 2x squared, no other like terms, plus 6x. And then we have a minus 2 and a plus 3. Those are like terms. I can combine those two. Negative 2 plus 3 is a positive 1. And there is our final answer. This is f of g. Okay. All right. And that's how you would compose two functions. It's simply another way to combine two functions. You're really essentially taking one function and using it as the input of another function. You're using it as the input x, replacing x with the other function entirely. Okay. Now, like I said, order does matter. So part B, we're still using these two functions, except this question asks us to figure out what is g composed with f. You might think that these two questions are the same, but they are not, because order does matter. So for part B, and I just want to reiterate, g composed with f, they could have also written that as, you might see, g composed with f of x. It's the same thing. Or maybe they might not even use that symbol. They'll just put g of f of x. That's also another way to write it. Okay. Now the way that we would set this one up, again, you start with the first function, the outer function. I call it the outer, but what I mean is which one comes first, which one is written first, and that in this case is g. So I'm going to refer to my g function, which is this whole x squared plus 3x minus 1. So I'm going to go ahead and write that. Instead of x, though, I'm going to leave just these empty brackets. X, or blank squared, plus 3. Instead of x, I'm going to just write these empty brackets. And then minus 1. So what I did is I took my g function, and instead of x, I put blank squared plus 3 blank minus 1. And then what I'm going to do next is I'm going to take the inner function, that's this f, that's the one that comes second, which is 2x plus 3. And that's what I'm going to put in place of these empty parentheses or brackets. That's going to be my new input. Instead of my input being x, it's going to be 2x plus 3. So that's what's going to go in place. 2x plus 3 in brackets squared plus 3. And again, instead of these empty brackets, I'm going to put 2x plus 3. Now this answer is right. It's completely correct. Our last step would be just to simplify, which means distribute or FOIL out. We do have 2x plus 3 squared. I'm going to do that out to the side. 2x plus 3 squared, that is 2x plus 3 times itself, 2x plus 3. So you would actually have to use either the FOIL method or the box method to figure out what that equals. You can't just do 2x squared and 3 squared, because that goes against PEMDAS. But if you wanted to FOIL, it would just be 2x times 2x, which I'll go ahead and just write it over here. I'll just write it right underneath, is 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. And 3 times 3 is 9. So right underneath my next line, I'm just going to go ahead and rewrite this. 4x squared plus 6x plus 6x, that's just 12x, plus 9. And then I can distribute this 3 to whatever's in parentheses. Positive 3 times 2x is 6x. Positive 3 times 3 is positive 9, and then we have this minus 1 on the end. And then our last part would be to simplify by combining any like terms. There's no other x squared term, so I'm just going to bring that down. There is a 12x and a 6x. Those are like terms, so 12x plus 6x is 18x. And then we have a 9 plus a 9, which is 18, minus a 1 is 17. And there would be our full answer. This is G composed with F. Okay, and you'll see that these answers are different, so that's why I say order doesn't matter. Make sure that you know, is it F composed with G or G composed with F? Because it does matter which one is the function that's written first and which one's written second. Okay. All right. All right, we're going to go ahead and do another example. So example number 2, it gives us two functions. The first function is f of x, and that's 2x squared minus 3. And the second function is 4x. That's our g function. So what we're going to do first is we're going to go ahead and figure out what is f composed with g. Now notice it has a 1. It's f composed with g. Before it was just f composed with g, or they can also write it as f composed with g of x. This one is f composed with g of 1. Okay. Now that does make a difference, but what we're going to do, we're going to ignore that 1 for now. And right now we're just going to figure out what is f composed with g. So I'm going to go ahead and try to solve it the same way I've been doing the previous problems. I'm going to go ahead and start with the first or outer function, which is the one that's written first, which is f. Now the f function is 2x squared minus 3. So I'm going to go ahead and write that. 2, and instead of x though, I'm going to write just an empty parenthesis or brackets, squared minus 3. So I took my outer function f, which is 2x squared minus 3, and I wrote that down. Instead of x, I just wrote empty parenthesis and brackets. And then what I'm going to do next is I'm going to take my inner function, or the second function that they give us, which is g, and that's 4x, and that's what I'm going to use in place of these brackets. That's going to be my new input. So I'm going to have, instead of 2 blank squared, it's going to be 2 times 4x squared minus 3. Okay. Now we've already figured out what is f composed with g, and that's what we got. We can simplify if you wanted to simplify. You could go ahead and figure out PEMDAS exponents first. What's 4x squared? Well, that's 16x squared times 2 is 32x squared, and then minus 3, and that's fine. I'll leave it as is because what the next part says to figure out is there is this 1. Now what that means is once you have your answer, and again, you can simplify if you want. I'll just leave it as is for now. Is you're going to take your answer and you're going to plug in 1 for x. So what this is going to equal, 2 times 4, and instead of x, I'm going to plug in the number 1 for x. Squared minus 3. And then I can just go ahead and figure out what that equals. Now, if you simplify this first, that's fine. It just involves more work. You'll get the same answer. So I didn't do that, but if you want to simplify, that is totally fine. And I'm going to just use my calculator. 2 times 4 times 1 squared minus 3, and you should get 29. If you didn't, make sure you included all those parentheses that we have on paper, just as it is. So the answer is 29. And this is f composed with g of 1. Okay, and there's our answer. All right, we're going to go ahead and do another one. For these next two examples, we're still using those same two functions. Obviously, it just cut off on the next page, so I'm going to go ahead and just leave this kind of at the top so you can see what two functions we're talking about. But example number 2, part B, this one is now asking what is g composed with f of 1. Now, ignore the 1. I like to do that last. Right now, we're trying to figure out what is g composed with f. So the way I'm going to do this, I'm going to start with the outer function, or the function that's written first, which is g, and that's this 4x. So all I'm going to write is 4, and instead of x, I'm going to just write empty brackets or empty parentheses. Okay. Now, inside the parentheses, that's what I'm going to plug in my inner function, or my second function they give us, which is f. Now, the f function is 2x squared minus 3. So that's what I'm going to write in place of those empty brackets. Okay. And you can simplify this if you want. If you want to multiply 4 times 2x squared and 4 times 3, that's fine. You don't have to, just because I already know we're going to plug in 1 for x and get an actual number and choose your calculator. Again, though, if you wanted to, that's totally fine. You don't have to, though. Whenever they give you like a constant to plug in at the end, I kind of don't simplify, just because I save myself a few minutes from, without doing that. All right, I'm going to go ahead and figure out what is 4 times 2. Instead of x, I'm plugging in the number 1 squared minus 3. And I'm just going to do the math using my calculator. 4 times 2 times 1 squared minus 3. And I got negative 4. So there's our answer. Okay, and this is G. I just like to label it. This is G composed with F of 1. Okay. All right, and then part C. This one looks a little funky. It says F composed with F of negative 2. Now notice it's the same letter twice. It's not a typo. It is F composed with F. So what we're doing is we're going to take the F function and compose it with itself, which is totally fine. So the way I'm going to do this is I'm going to start it off the same way I started the others. I'm going to start with the outer function, or the first one, which is F. And I'm going to refer to the F function, which is this 2x squared minus 3. I'm going to go ahead and write that down. Every x value, though, instead of the input being x, I'm just going to write these empty kind of brackets or parentheses. So 2 blank squared minus 3. Make sure the squared goes on the outside of the parentheses. You're only putting brackets in place of x. All right. All right, and then my next step would be to take the inner function, or the second function they give us, which also happens to be f, which is, again, 2x squared minus 3, and that's what you're going to put in place of those empty brackets. So I didn't leave enough room, but I'm going to try to squeeze 2x squared minus 3. Okay, so it's really the same function, kind of twice. And then you can simplify this if you wanted to. If you did want to simplify, you would have to use the PEMDAS order, so you would have to use a box method by 2x squared minus 3 times 2x squared minus 3, and you can do FOIL or box. But I like to skip the simplifying step just because I'm going to plug in negative 2 for x, so I kind of don't worry about that. So what I'm going to do next is I have my answer. It's right. It's not simplified, but that's okay. And I'm just going to plug in negative 2 for x. So it's going to be 2 times 2. Instead of x, I'm going to plug in the number negative 2, because that's what the x value they give us. This is the little x value. And then squared minus a 3. Make sure you include all the brackets that you had from above. Squared minus 3. Okay. So all I did was kind of just take this x. I plugged in a negative 2 for it. I just wrote it much bigger. And I'm going to go ahead and type this whole thing in. And I will get 2 parenthesis, or bracket 2, times negative 2 squared minus 3, close parenthesis, squared minus 3. And I got 47. And so there's our answer. Okay, and this is F composed with F of negative 2. All right, and there's our answer. Okay. All right, we're going to go ahead and just do we'll do 2 examples. A few more examples of just those kind of problems, again, so just to get more practice, and then we'll move on to the next part. Okay. So, example number 3, once again, same thing. It gives us 2 functions, and it says to find each of the following. So first thing I'm going to do is I'm going to start with part A, figure out what is F composed with G. Start with the first function, which is F, and that's this first one, 5x plus 6. So I'm going to write that down. 5. Instead of x as my input, I'm going to just kind of have these empty brackets or parentheses, and then plus 6. Okay. Alright, and then my next step is to take the inner function, which is this g function, and then I'm going to put that in place of these brackets. I'm going a little faster on this example just because this is really just some practice. Hopefully kind of get a little bit of the gist by now. And then I'm going to simplify because it doesn't have a constant to plug in, so I'm not going to use my calculator for this because I can't type it next. So I would just simplify, and this will equal 5 times 2x squared is 10x squared. 5 times negative x is negative 5x. 5 times negative 1 is negative 5, and then plus 6. Okay. I can simplify this just one step further because there's some constants that are like terms. So this is going to equal 10x squared minus 5x. Negative 5 plus 6, those are like terms. So negative 5 plus 6 is a positive 1. And there's our answer. And this is f composed with g of x. I just like to label my answer so I know what it is. Okay. All right. Alright, same thing for the next one, part B, except this one is asking us to figure out what is g composed with f of x. So I'm going to start with my outer function, or my first function, which is g. So it's going to be 2 times x, which instead of x, I'm going to go ahead and leave some parentheses, squared, minus, instead of x, I'm going to go ahead and put some brackets or parentheses, minus 1. My next step is to take the inner function, or the second function that's written right here, which is f, 5x plus 6, and that's what's going to be my new input. So it's going to be 2 times 5x plus 6 squared minus 5x plus 6, and then minus 1. And this answer is right. Last step would be just to simplify. There's no constant that we can plug in for x at the end, so we would actually have to simplify this. We have 2 times 5x plus 6 squared. Now, common mistake that students might try to do is they might try to figure out what is 2 times 5x and then 2 times 6. You can't do that. You can't multiply before you take care of the exponents. It goes against the rules of PEMDAS. You have to take care of these exponents first. Another thing that students might try to do is, oh, well, let's figure out what's 5x squared and what's 6 squared. You can't do that. You would have, because you're basically trying to apply it to it individually. You have to square this first. And the way you can do that is either using the FOIL method or the box method. So 5x plus 6 squared just means what is 5x plus 6 times itself, 5x plus 6. That is what 5x plus 6 squared means. Sorry. And I'm going to go ahead and use the FOIL method. 5x times 5x is 25x squared. 5x times 6 is 30x. 6 times 5x is 30x. And 6 times 6 is 36. I can simplify this by combining the middle-like terms. We have 25x squared plus 30x plus 30x. That's the same thing as just plus 60x plus 36. Okay. Now that's not the final answer. All I did was I kind of did the math right here on what is 5x plus 6 squared. So back to my problem. I still have this 2, so don't forget about the 2. And then I now have 5x plus 6 squared. I did the math on that, and that's what I got. I got 25x squared plus 60x plus 36. I know the ones that involved you to do the FOIL and box method can get a little, tedious and time consuming. Those are just kind of the ones, that involve more work. I kind of prefer when it was more simpler without the FOIL method. But some questions might be like that, so I wanted to do at least a few here. We have minus 5x minus 6, because I'm subtracting both of these terms. Minus 5x, it's like a negative 1 times 5x, and a negative 1 times 6 is negative 6. And I still have this minus 1. Okay. And then I would just distribute this 2. Let's see, I have 2 times 25x squared is 50x squared. 2 times 60x is 120x. And 2 times 36 is 72. Minus 5x minus 6 minus 1. All right, I've foiled everything out. Last step just would be to comb through it, see if you have any like terms. 50x squared, there's no other x squared terms, so that's just going to be brought down. We do have 120x, and we also have minus 5x. 120x minus 5x is positive 115x. We have some constants that we can combine. 72 minus 6 minus 1. 72 minus 6 is 66. Minus 1 is 65. So this would be plus 65. And that would be our final answer. Okay. All right. And then last part, it says figure out what is G composed with F of 3. Now the cool thing is we've already figured out what is G composed with F. That's the answer that we got on this last part right here. So all we have to do now is just take our answer from the previous problem and plug in 3 for x. That's really all I'm going to do is I'm going to plug in 3 for x. So I'm going to take this final answer and I'm going to just take every x and replace it with the number 3. Squared plus 115 times 3 plus 65. And I'm just going to use my calculator for that. 50 times 3 squared plus 115 times 3 plus 65. And I got 860. I just like to label my answer, so I'm going to go ahead and write that again. There you go. Now earlier I said if you ever have to plug in a number, like a constant at the end, like g of f of 3 instead of just like g of fx, you don't have to simplify. So like what I meant by that is like for the previous problem, g of f of x, this is what we got. We simplified all that. I know we did the FOIL and we distributed. We could have, like for this next problem, I'm trying to show both without covering it. Like if we got this as an answer, let's say we didn't want to simplify, and the next part asked you to figure out what is g of f of 3, you could have taken this answer and plugged in 3 for every x. What I mean by that is you could have taken this answer 2 times 5 times 3 plus 6 squared minus 5 times 3 plus 6 minus 1, and you'll get the same answer. See, 860. That's what I mean. Anytime you have to plug in a number at the end, I kind of skip all the simplifying. I just plug in the number 3 for x early on because you'll get the same answer. That's what I meant. Okay. All right. All right. All right. Moving on. Example number 4. It's the same process. I just included this one. I took this one actually directly from your Mind Math Lab homework, so most of you might have the same exact problem. If not, almost identical, just maybe different numbers, but pretty similar. And it's the same thing. It just has square roots and fractions, so you might get a little thrown off, but it's the same process. So example number 4 gives us two functions, f of x, which is the square root of x plus 4, and g of x, which is 3 divided by x. And the question A is asking us to figure out what is f composed with g. Now there's no constant that we're going to plug in at the end. And remember, sometimes they write it like this. Sometimes they also might write it like f of g of x. So I'm just going to write it both ways so that you know that you can also see it written like this. F composed with g of x. Same thing. Okay. It just means that you're going to leave x as it is. You're not going to plug in a number for x at the end. All right, so the way that we solve this, start with the outer function, which is the first one they give us, which is f, which is the square root of, and instead of x, I'm going to go ahead and leave brackets or parentheses for x, and then plus 4. All right, second part, I'm going to take my inner function, which is g, and I'm going to, which is 3 over x, I'm going to take that and plug it in to my empty brackets. So 3 over x will be my new input. Okay. And there's really not much you can do. You could try to get a common denominator, put this over 1, but you really don't need to, so I'm just going to leave it as is, and that is totally fine. Okay. Make sure the square root is over everything. All right, and then part B. Part B is asking us to figure out what is G composed with F. Again, you could have also seen it as G composed with F of X. Same thing. I just want you to get comfortable with both notations. First step, start with the outer function, which is the first one they give us, which in this case is G. So that's going to be this 3 over X. So I'm going to write it as 3 divided by, instead of X, I'm going to go ahead and just use parentheses or brackets. Doesn't really matter. And then second step is to take your inner function, or the second one they give you, which is the square root of X plus 4. And that's what you're going to put in place of those empty parentheses or brackets. So it'll be 3 over, not X, 3 over the square root of X plus 4. You can't simplify that any further, so you can just rewrite your answer. That's pretty much it. 3 divided by the square root of X plus 4. Okay. And that's it. All right, so hopefully you got enough example practice problems with two functions and how to compose them. And then the next part that I want to do is, and you're going to get some like this on your My Math Lab homework assignment. So I wanted to do at least one. Sometimes you'll be given a table and it's asking you to compose two functions. Given the table of values. Okay, usually what we've been doing is we've been given two equations and we have to compose them mathematically or algebraically. This time, instead of giving the equation, we're just given the table of values. So what we're going to do is we're going to go ahead and do a few examples. We'll start with the first one, part A. Notice there's 3 rows in this table. There's X value. These are all the X values. Second row is F of X. Meaning like if you take negative 3 for X, plug it into your F function, that's what you'll get as an output. And then the last row is your G of X values, meaning if you use these X values up on top, you plug them into your G function, that's what you'll get as an output. Alright, so let's go ahead and start with the first part, which is F composed with G of 1. Now, when I'm given a table, I know I always say start with the outer function, start with F. But when I'm given a table, I actually do it the opposite. I start with the inner function. Okay. Now remember, you're going to see it written as F composed with G of 1. You might see it like that. You might also see it written as F composed with G of 1. That's another way to write it, and that's totally fine. Okay. So just know that these two notations are the same. That was part of the definition. You're going to see it either way. It means the same thing. Okay. So you can see it written like that as well. And I actually prefer it like this when I'm dealing with a table, because what I'm going to do first is I'm actually going to start with the inner part, which is G of 1. Now what that means, I still have this F, and I got to figure out what is G of 1. Well, what that means is when your X value is 1, so I'm going to go to my X row, when X is 1, what is the G function worth? Well, so when X is 1, the G function will be 0. So that's actually going to be in place of G of 1. So again, what I did is, this is just figure out what is G of 1. That just means when X is 1, our G function value will be 0, our output value. So I put G of 1 is 0. And now what I'm going to do is, I'm going to do the same thing now, figure out what is F of 0. That just means when X is 0, what is the F function's value? So when X is 0, go to your top row, that's X. When X is 0, the F function will be worth 5. So this whole thing is equal to 5. And there's our answer. Okay. Alright, another example, F composed with G of 2. I'm going to actually write it like this, F composed with G of 2. I prefer that way when I'm dealing with a table. And when I'm dealing with a table, I know I always start with the outside and work my way in. I actually do the opposite direction. I start with the inside function and then work my way out. So G of 2 is like the inner part. So I'm going to go ahead and go to my table. What this means is go to when your X value is 2. And what is the G function worth when X is 2? So when my X value is 2, that's this last column, the G function, the output value for G will be negative 3. So this is just going to be F of negative 3. Okay? Right here. Alright, and then I'm going to do that same thing again. Now I'm going to go to when x is negative 3, what is the f function worth? So when x is negative 3, the f function, the output value for f of x will be 11. So this whole thing is just equal to 11. And there's our answer. Okay. Last one, that should actually be part C, little typo. G composed with f of 2. I'm going to go ahead and write it using this notation, g of f of 2. Just another way to write it. I prefer it this way because I'm going to start with the inner function, which is f of 2. That just means when x is 2, what is the f function worth? So when our x value is 2, the f function is 1. So this is just going to equal g of 1. Okay. And then same thing again, when x is 1, what is the g function worth? So go to my x row, when x is 1, the g function, the output value for g will be 0. So this whole thing equals 0. And there's our answer. Okay. Alright, so that's how you would compose functions given the table of values. Alright, and then the last way to compose two functions is given a graph. So we went over how to compose two functions given the two equations, given a table of values, and then the last way to compose two functions is from a graph. So let's say you're given a graph of two different functions. This top darker one is our f function. I don't know if you can see it. I'm going to go ahead and I'll go ahead and highlight it with pink for the f function, so you can see it a little bit more clearly. And that's our f function. Okay. I don't know if you can really see that on the document camera, but hopefully you get the point. All right. And then the second function that they give us is this g function. I'll just go ahead and make that a little darker for you to see. So they gave us two functions. I'll also highlight the g function so you can see a little better on the document camera, on the video. Okay. All right, hopefully that's better. All right, so question 6, part A, gives us 3 different examples. It says figure out what is g composed with f of negative 1. Now, you can go ahead and leave it like that. Anytime I'm dealing with a table, though, or a graph, I prefer to write it like this notation. Some of you might be thinking it doesn't really matter. I mean, do you really have to write it like that? No, that's just my personal preference. You can go ahead and leave it as is. I just like to write it like this when I'm dealing with a table or graph. All right, so the way we're going to start this is, once again, we are going to start with the inside part, work my way out. Okay. Anytime I have a table or graph, I like to work with the inside and then work my way out. So the inside part says figure out what's f of negative 1. That just means look at your graph. When x is negative 1, figure out what the f function value is at. So that just means I'm going to start with my f function, which is this pink one. And when our x value is negative 1, so look at your x-axis, go to negative 1 on the x-axis, which is right here. So when x is negative 1, what's the f function worth? So I'm going to trace it up to my pink f function. The f function, or the y value, is 4. See, the y value at x is negative 1, the y value is 4. So this question is just g of, well, 4. Okay. All right, I'm going to do that same process again. Now I'm going to look at the g function, figure out when x is 4, because this is x. When x is 4, what is the g function y value? So I'm going to go to my purple function, go to when x is 4, so go to the x-axis, go to 4 on the x-axis, and the purple function, well, it's right here. The purple function has a y value of 0. So that just means this whole thing equals 0. Right here. Okay. And there's our answer. I didn't leave much space for this, but hopefully more space on the next one. Okay. All right, next one, g composed with f of 0. I'm going to go ahead and write it as g composed with f of 0 using this notation. And I'm going to start with the inner part, figure out what is f of 0. That just means look at your f function, figure out when x is 0, what is the f function's value, what is the y value. So go to your x-axis, go to when x is 0, which x is 0 is right here. So when x is 0, what is the f value? What is the y value for this pink function? So the y value when x is 0 is right here. It's positive 3. So this is just g of 3. Okay. And then I'm going to do that same process again. Look at my graph. Now we're looking at the g function, which is this purple one. And I'm going to look when x is 3, what is the g function worth? So when x is 3 on my x-axis, which is right here, what is the y value? What is the y value of the g purple function? And the y value when x is 3 is positive 1. So this whole thing equals 1. There we go. Alright, and then last one, part C, f composed with g of 3. So I'm going to go ahead and rewrite this as, what is f composed with g of 3? Start with the inner function, which is g of 3. Start by figuring out when x is 3, what is the g function worth? So g of 3 just means go to your x-axis, which is, go to 3, and figure out what is the y value of the g function, meaning the purple function. So the purple function, the g function, the y value when x is 3 is 1. So this is just f of 1. Alright, and then I'm going to do that process again, figure out when x is 1, remember this is x, what is our f function worth? So when x is 1, go to my x-axis, x is 1 is right here. The y value of the f function, of the pink function, is, I'm going to trace this x value 1 up to the pink function. The y value is right here, it is positive 2. So this equals positive 2. And there's our answer. All right. And that's how you would compose two functions from a graph. All right. Okay, last question. I just included this one. You might already know how to do it. I just included this one because there was 2 questions, I think, at least, on your my math lab homework assignment that asked you to do problems just like this one. And example number 7, it gives us 2 functions, once again, the equations. The first one, f of x, is 3x minus 4. The second function, g of x, is 1/3 times x plus 4. And it says, show that f composed with g of x is equal to, it's the same value as g composed with f of x, and all of that equals x. And it's a lot of statements, but what I'm going to do is I'm just going to figure out what is f composed with g of x, do the math on that, and then I'm going to figure out what is g composed with f of x, do the math on that, and hopefully they'll be equal or the same answer. So I'm going to go ahead and start with f composed with g. I'm going to go ahead and write that out to the side over here. So f composed with g, remember when we're dealing with the equations, I start with the first function or the outer function, which is f. That's this 3x minus 4. So I'm going to write that again. So I'm going to have 3 times, instead of x, I'm going to just kind of use empty parentheses, or you can use brackets if you prefer it, minus 4. Okay. And then my second part is I'm going to take the second function or the inner function, which is g, and that's what I'm going to put in place of these empty brackets or parentheses, which is 1/3 times x plus 4. So 1/3 times x plus 4. Okay. Alright, I've set it up, so the next thing to do would just be to simplify. Now there's quite a bit of parentheses here, so what I'm going to do first is I'm going to go ahead and simplify the inside of the parentheses. I have 1/3 times x is just 1/3 x. 1/3 times 4 is, 1 times 4 is 4 over 3. Because this is like 4 over 1. So it's going to be numerator 1 times numerator 4 is 4. Denominator 3 times denominator 1 is 3. Minus 4. And then I'm going to distribute this 3 to everything inside the bracket. So 3 times 1/3 x. Well, 3 times a third is just 1 whole. You can write 1 whole, or you can just leave the 1 off, and then we have x. Okay. Then I have 3 times 4/3, which 3 times 4/3 is just 4. And if you're getting confused with the fractions, you can always use your calculator to double check some of the math. But 3 times 4/3 is just positive 4. And then we still have this minus 4 on the end. And this equals, let's see, x plus 4 minus 4. Plus 4 and minus 4 cancel out. And I'm just left with x. Okay, and so this was our first part, f composed with g of x. And it says, show that it equals, show that this whole thing equals x, which we've done. So we've done half of the question. And then the second part says, also show that g composed with f of x is equal to x. So I'm going to go ahead and do the math on that. Go ahead and separate this 2 parts. And I'm going to do it again. So now I'm figuring out what is g composed with f of x. This time I'm going to start with the first function, which in this case is g, which is this 1/3 x plus 4. So I'm going to have 1/3 x. Instead of writing x, I'm going to go ahead and write just kind of like these empty brackets or parentheses for x, and then plus 4. The second part would be to take the inner function, which is the f function, which is 3x minus 4, and that's what's going to go in place of these empty brackets. So 3x minus 4. Okay. All right. You can kind of go ahead and do a few things. You could probably distribute the 1/3 to everything. It's up to you. I'm going to go ahead and just take care of the inside of these parentheses. I have 3x. There's nothing outside of the bracket, so I can just go ahead and write 3x. I have a minus 4, and then I have a plus 4. Minus 4 and plus 4 cancel out. It's just 0, so it's just nothing, or 0. And then I have 1/3 times 3x. 1/3 times 3 is 1 whole. You can write a 1 whole, or you can just write x. And that's what we got. And what do you know? These two answers both equal x. So we got the same answer, and they both equal x. So we've done that. We've shown that these are equal. Okay. All right, and that wraps up the composite functions lesson.